Dear students, welcome to our class on Indian monsoons, 3 oceans. So, in this class, we try to understand what are the effects that are caused by two things. The atmosphere over the ocean, this is what atmosphere over the oceans. Number 2, oceans themselves through ITCZ, Intertropical Convergence Zone, ITCZ we call it. Now, see, in the first class of the Indian monsoon, we tried to understand during the months of March, April, May, the Indian subcontinent gets heated up. There is a sensible heat. Low pressure is developed over the land mass as compared to the eastern side Bay of Bengal, western side Arabian Sea, southern side Indian Ocean. The differential heating of this bit will come. Differential heating of land and ocean or land and water causes the two things. Number 1, temperature difference of the land and oceans and pressure. So, differential heating of land and oceans through sensible heat and latent heat. What is latent heat? From the southwest monsoon, we get the warm moist winds. Those warm moist winds, when they become clouds, and then condensation occurs. Condensational cooling. That's what we call the latent heat. So, here we can firmly say that there is a relation between the atmosphere over the oceans. There is a relation between the atmosphere of oceans and oceans themselves. Atmosphere, what is atmosphere? Atmosphere is a colorless, odorless and tasteless physical mixture of gases enveloping the earth on all sides. Means, both lithosphere and the hydro oceans. So, let us be very clear. Over the oceans, there is the ocean atmosphere and oceans. These two are entirely different. So, oceans play an important role. Atmosphere over the oceans play an important role. How? We try to understand in this class. Then, of course, ENSO, El Nino and Southern Oscillation, how it affects Indian monsoon. And finally, there are some telecorrections. Now, here, so I would like to share with you a substantial fraction of the large-scale rainfall over the Indian region occurs in association with the propagation of a synoptic scale system from surrounding seas or oceans. Now, what is the meaning of it? A substantial amount of rainfall over the Indian subcontinent occurs because of this line. So, propagation of synoptic scale systems from surrounding seas. Propagation of synoptic scale systems from around the seas. So that is ocean, number 1. Okay. The variability of the monsoon is linked to, what is the variability? In the second class I discussed with you elaborately. That much is enough for our agriculture meteorologists. Indian monsoon, first class mechanism, second class variable, third class oceans and atmospheric oceans. To the extent that we, the agrometeorologists, should learn. There I can find to this line. See, the variability of the monsoon is linked to the facets of oceans and the atmosphere over the oceans. This is the third class. Here, hence, even though we are much interested in the rainfall occurrence, temporal or spatial variations, time-wise or space-wise variations, or area-wise, we confine to land because we are growing crops, agriculture, horticulture, plantations, all these things. However, we should take into consideration the atmosphere over the oceans and oceans because differential heating of these only decides the mechanism. Now, so, of course, Halley in the year 1686, way back over 300 years ago, himself told the differential heating of land and oceanic areas is the basic cause of basic mechanism of the Indian monsoon, and it is a large scale land and sea breezes line. Large scale land and sea breezes, large scale, not small scale. So, here, the differential heating of the land and sea is considered as the basic mechanism for the monsoon. Okay, this is at the system scale. However, there is at uh, a planetary scale is there. Now we discuss about the IT season, intertropical convergence zone, planetary scale. See, of course, as far as limited synaptic scale level is concerned, okay, the differential heating, but intertropical convergence zone at the planetary scale level, how it is influenced. Which one? Indian monsoon is influenced. That's what we are going to understand in half minute. What is that? There is an alternative hypothesis in which the monsoon is considered as a manifestation of a monsoon occurrence. So distribution is considered as a mechanism of, as a manifestation of the seasonal migration of the intertropical convergence zone, which is also known as the equatorial trough, we call it as, in response to the seasonal variation of the latitude of maximum insolation. Seasonal variation of maximum insolation. Once again, the third time I will tell. Intertropical convergence zone is the second way of explaining the mechanism or variability of the rainfall. Now, the intertropical convergence zone, okay, which is also known as equatorial trough, we call it as, because incomplete, the system is incomplete system. So, semi-annual also, sometimes in some books of older generation books, 100, 150 years. So, monsoonal trough or equatorial trough, they have mentioned like this. Now, so this is another important thing I would like to share with you, that after 2 minutes I will say, when ITC that goes to north, when ITC goes to south, what will happen. After 2 minutes I will discuss it. Before that we should understand what is ENSO, El Nino and Southern Oscillation. See, Central Pacific and eastern parts of Pacific Ocean. Central and eastern parts of the Pacific Ocean, when it gets heated up, warmed, we get El Nino. During the El Nino year, we get droughts. Exactly reverse. Central Pacific and eastern equatorial area, eastern equatorial area is a Pacific region. When they become cool, La Nina, we get copious amount of rainfall. This is an established factor through Monix expert. See, different, for the last 30 years, enormous amount of research. Observations have taken. This was established. This is established. What is it? El Nino years, droughts in India. La Nina years, it is excess rainfall in India. 17.6% of the 136 years. That means out of 136 years, 24 years are drought. 2 monsoons, Indian monsoon, 2 I told. 19 years of excess rainfall. That means 13.6%. So, of the 130, the remaining are normal years. But even in the normal years, the variation interannual is less, but intra-seasonal is very, very high. In terms of temporal and spatial. So, a question will come. You should write. What are the reasons for the variable? These are the reasons. Agriculture meteorology side only. I am not talking much about pure climatology of Indian monsoon. Indian monsoon, climatology with respect to agriculture meteorology we are discussing now. Okay. Now, so convection, usually convections over the equatorial Indian Ocean. Equatorial Indian Ocean, okay, is the onset phase, okay, in the onset phase. Equatorial Indian Ocean convection. Convection occurs in the equatorial Indian Ocean. In the onset phase is very important in the intra-seasonal and interannual variation of Indian summer monsoon rainfall. Indian summer ISMR, yeah, okay, ISMR only, okay. Indian summer monsoon rainfall. What is the another important scientific reason? Equatorial Indian Ocean convection over the equatorial Indian Ocean during the onset phase, it determines. Second thing, the onset phase comprises, of course, here when I was talking about intertropical convergence zone, it is a planetary. Now, Here the scientific reason I told 2 minutes back. I will be telling you what is the importance of intertropical, that is the equatorial trough. That's good. With reference to rainfall from rainfall variation point of view. Now, the onset phase comprises northward propagation of intertropical convergence zone from equatorial Indian Ocean and westward propagation of synoptic scale from the Bay of Bengal. Okay, the onset phase of the Indian monsoon is determined by intertropical convergence zone moving towards north and western propagation of the synoptic scale systems, particularly from the Bay of Bengal. This is one. This is with reference to onset. Once again, if I am interested to explain to you once again that intertropical convergence zone, northward movement and synoptic scale systems from the Bay of Bengal to the westward, they determine the onset of the Indian monsoon. This is what. Okay. Now another important point. One of the major achievements of the last 2 decades, particularly for the last 30 years, one of the best one of the scientific investigations results of scientific. El Nino, La Nina, El Nino yes drought, La Nina yes, okay, excess rainfall. That's what. So like this, we have very good results from the India Meteorological Report. Now we try to understand in 1.5 minutes what are the telecorrections. Telecorrections means, Earth is elliptical in shape. Earth makes one rotation around itself in one day. It makes one rotation around the sun, say in 364.5 to 365 days. Now, there are some telecorrections as far as Indian monsoon is concerned. Whether to know the interannual, intra-seasonal or diurnal or millennium variations in the rainfall, one should understand to some extent the telecommunication. Frankly and honestly, I have reviewed so many scientific papers for over 30-35 years. What all the research findings with reference to telecommunications or large scale systems or planetary scale systems like ITCs are concerned, all the scientists, topmost scientists across the globe, particularly India Meteorological Department, always concluded that high power simulation model, coupling models, more and more observations are needed to establish telecommunications with reference to Indian monsoon. Because they are playing a significant role with reference to onset, with reference to withdrawal, with reference to variability, interannual, interseasonal. So, lot of research is required. Still, the findings of the research so far, I would like to share with you that, number one, Indian summer monsoon, which is a part of the Asian monsoon, demonstrates degree of variability on intra-seasonal, interannual and multi-decadal. That's what we discussed in the second class. So, Indian monsoon, which is a part of the Asian monsoon, intra-seasonal, interannual, in between the years, within the season, and decadal also. Variations are there. Now, so there are, 4 global, there are not 4, certain, I am not limiting it, we discuss only 4 or 5, but there are others also. Global connection patterns influences the interannual variability of Indian summer. Interannual, in between the years, because on both the hemispheres display. So I just try to name. M.Sc is the number 1, El Nino and Southern Oscillation, that is the number 1. Number 2, Indian Ocean sea surface temperature, wonderful. Equatorial Indian Ocean oscillation, 3 to 7 days. That's what we discussed in the second class. North Atlantic sea surface temperature, land surface anomalies including snow cover and snow depth over Eurasia and Himalayas. So, these are all the things which are having some teleconnections with the Indian monsoon. All these teleconnections are not independent. They are not independent and are having complex interactions. There, the India Meteorological Department, there the scientists working globally on the monsoon, Asian monsoon, suggest that high power simulation, model, coupling of the models, different inputs, different feedbacks, different inputs and different feedback from different sources are required for establishing this telecommunication. Once we establish these telecommunications, yes, Indian monsoons variable, interannual, intra-seasonal, diurnal, millennium, everything would be further available to the society. Agriculture is more and more so to the policy or decision makers. Now, see, here I would like to share with you that ENSO is known to be the most important global phenomena influencing the environment. There is no doubt at all. And so, in the last class we discussed it. Here also, ENSO is undoubtedly the deciding factor. El Nino, Southern Australia. El Nino, yes, drought. La Nina, cool. Pacific Oceans, central part of Pacific Ocean, and to the eastern side. Okay, everything. Now, another one important line I would like to share with you is that there is no convincing answer why some El Nino years are extremely drought. One of the possible reasons is sea surface temperatures warming over the central equatorial Pacific. Central equatorial Pacific warm drought for India. I repeat once again, central equatorial temperatures in the Pacific. Central equatorial Pacific temperatures drought in India. Now, the last point I will share with you on the interannual time scale. The Indian monsoon is strongly linked to the sea surface temperatures of the southern Indian Ocean, where large scale sea surface temperature appears. Indian, lower scale, Indian Ocean surface temperature increase. Okay. Intraseasonal, within the season, okay, intra-seasonal variation in the monsoon rainfall occurs. This is what I would like to share with you. Thanking you for your very patient hearing.